Okay, yeah, this is Tom Cox from Cummins Engineering in Springfield, Illinois. I just want to go over this ADA ramp, this proposed ADA ramp that's located in Clinton, Illinois at the intersection of Center and Webster Streets. So here's the situation. At the back of the sidewalk, of course, is the existing right-of-way. You can see that the sidewalk's up high. Also on the side road has a grade of about 6%. So there's a challenge. Center Street profile is going downhill some. You saw the stairs back there. We also need to get this alleyway taken care of. Again, very steep slope, and we're very confined. So anyway, we needed to design an ADA ramp, and not by right-of-way in this case, which can be challenging. But we came up with the design, and so here's what we came up with. If we look in the 3D view, you can see the proposed design. We could also turn on the existing, if desired, the existing terrain. So you can see the existing ground surface anyway. So here's what we have. Of course, one of our biggest challenges was dealing with this side street that is at 6%. So the way that we do that, and really what you're aiming for in the beginning here, is to get that 5x5 turning space, which is located right here. So the way that we're able to do that is once we get that existing profile along the existing pavement identified, we can apply the linear template and place this B612 curb and gutter, and then include the depressed areas, and then we're going to build off of that. And so what we did was we came up with the maximum slope to try to get up to that elevation. So if it is 8.33 or 1 to 12, which you can see there. I can come down here, and if I want to look at the profile graphically, what I can do is I just select that line, and then I can click in this profile view over here, and then I can see both the existing and the proposed graphically, and then I'm going to select that proposed profile, and there you can see it graphically. It's a 8.33, and so that's what we have here. Really, the easier way, rather than graphically looking at the profiles, is probably just to analyze any of these features. So if I analyze that same location, you can see as I move my cursor around a little bit, it changes the attributes of whatever that line is. It shows me the direction of flow, and then I can see the slope is 8.33, just like we saw in the profile view. So let's do that from now on, since that's just so much easier. And that's what's nice about this 3D modeling, is that we can look at the profile of any line, not just simple line, a handful of lines like we typically would. Same here. I can select the edge of this 5x5 turning area, and you can see the direction of flow and the fact that the slope is 1.5%. Okay, so from that, we've got that identified, and then really it's just a matter of, so now we've got this ramp, we've got the turning area, now we just need to connect that to, and of course that slope cannot be greater than 8.33. And even though we're going up at that maximum slope, we're still a little bit below that location. So you'll notice when I click on the edge of the sidewalk, you see the direction of flow, and you see that it's only 4.18, which is fine. No problem here, because if any water does get over that depressed curb, it's just going to come right back down that sidewalk. So we're not going to trap any water. Okay. Next, we can come over here and look to see, like I said, this is a fairly steep slope. Now we're lower. We need to get tied back in. So how are we going to do that? Well, we are going to run the profile of the sidewalk up at our maximum slope, which is 8.33 as a maximum. So let me go ahead and bring up that profile view. I select the profile and you can see we're under the max. So we're actually tying into a joint in the sidewalk right before it gets to the entrance. And you can see that our slope is 8.18, and that's over 50 feet. Okay. Also, if we look over here in Street View, you can see that the property owner uses this area in front of the sidewalk for parking, so we're going to try to keep that. And also, one other thing you might need to know is this tree is now dead, so we can remove this tree. And so what we're going to do here is we're going to pull the sidewalk out away from the right-of-way just a little bit so we can get tied back in. And actually not even need a temporary easement, amazingly enough in this case. Okay, let's spin around a little bit. And what we're going to do here to deal with this slope and with the fact that the sidewalk is up high, okay, so instead of putting the sidewalk there, we're going to move it down a little bit closer to the curb and gutter. So we went 3 foot off the back of the existing curb. Now we need to try to go up as much as we can, you know, but not too much. And so we went up at a slope of 33% or a 1 to 3 over 3 foot, which is fine. And then so we will not need a curb or retaining wall or anything on the roadside. So just to get tied in with the sidewalk there. And then, of course, the cross slope of the sidewalk is going to be 1.5%. And then we put a 6-inch curb on the back of the sidewalk. And then from there, we need to get tied in by the existing right-of-way. So we can do that by connecting the top of this curb with the existing right-of-way, and that is 25%. So we end up with a 1 to 4 slope, which is completely acceptable. Now we need to put back the stairs for the property owner, and in this case, because the sidewalk or stairs for the property owner are strictly for the property owner, not the general public, you can have stairs, and so we're going to put back those stairs. And you can see that is in place with no problem. Okay, let's move down the design a little bit, get a little bit closer to that alleyway. Okay, so here, like we said, that alley is very steep. I think it might be around 8% or so. I don't remember the exact slope, but I can tell you it's very steep. So what we're going to do is we're going to saw cut that concrete apron of this alley right where the sidewalk crosses. So that's what you're seeing right here. You can see that there's a saw cut there. And so now that crossing across the alley needs to be 1.5%. And so we got that designed. And so really it was just a matter of connecting the two, connecting that point with the point down here along the sidewalk that's closer to the roadway. Also, we're up high in elevation. So what we needed to do with that profile is we take that up at a maximum of 8.33 and then get it tied back in. So I think that was like 2%. We can analyze that real quick. Again, like I said, all I need to do, click on that feature line. And yeah, you can see there, it's coming down at 2.66. If I go near this ramp area right here, you can see that it's 8.33. And then that gives us a maximum height in that curb along the sidewalk of 18 inches. So it's not really, I guess, technically a retaining wall. It's still just a high curb that's manageable. Okay, now let's look at the other side of the alley. And here we need to get connected into this sidewalk that goes into this residence, that door right there. And so again, as you know, a maximum 8.33%, so connect the dots, so to speak. But what happens there is we end up lower than the existing sidewalk. So what we need to do here is we need to add one step in order to bring that sidewalk down so we can get tied in and still be less than 8.33%. So let's see what we ended up with. 7.75%, which is completely fine. And then when we get to the top of the ramp, we've got our 1.5% a flat area directly in front of that sidewalk. And then from there, we can get tied into the existing. And again, if I want to click on there, you can see that I can get tied in at a 0.41%, no problem. We can get tied back into the existing. And the reason we are able to do that is the existing starts coming back down, so it's not too difficult to get tied back in. Now, let me mention this too. On this alleyway, because we only went with a 1.5% crosswalk across the alley, of course, that brings us down on the existing ground line. And here, if I look, I guess I could look at graphically at, say, like this line here, for instance. I'll visualize that profile, and you can see down here that we are well below the existing, right? Okay, so now we need to get tied back. We need to get that alley tied back in. So we can do that with just ag, no problem. We don't want that to be too steep. So what we do is in this case, it would be acceptable to tie in with an 8% slope. So I'm just connecting the dots. I'm taking that profile and I'm running 8% until it ties into existing. And then because we were up, or we're below the existing here, then all I did here was just kind of wrap around that curb for, I think it was over 7 or 8 feet was all. And then we can get that tied in nicely, all staying off private property. And that is our solution to this particular ADA issue. We'll see you later. Thank you.